In a previous video on lathe duplicators, at the end of the whole process of using the lathe duplicator, I actually went to a CNC version of duplicating chair legs. And I had some requests in the comments to show that system, and now I've actually got it to the point where I can show it off. I've got the mechanics a little bit better. This is a very specific situation. I have a 4x4 CNC. I don't have a rotary access module for it. I can't afford it right now. And I also don't have fourth axis software like Vetric. I'm just using Easel, which is very basic and can do a basic 3D carve. So this is how I dealt with this very specific situation. Maybe you're in the same situation. You have CNC and you can put together a very rudimentary lathe. So I've got an axle with pillow blocks. I've got it being run by a slow speed motor that I can go anywhere from 10 RPM to about 100 RPM. I can go forward and reverse. I'm actually only using one direction. Headstock, tailstock. I've got a piece of wood, a blank. The headstock simply has a 1/2-inch bolt to hold the wood on, and the tailstock just has like a live center. I'm going to turn it on right now and you can see it spin. So right now it's spinning at 80 RPM. I've got a spindle blank up and spinning, but how do I actually carve it? I'm going to do a very slow pass from front to back, and I'm going to kind of fake it by simply programming a thin channel. I'm going to get the CNC to go very slowly and go from end to end and just draw that profile. And if the wood wasn't spinning, all you would get was that little profile. But because it's spinning, the CNC is moving very slowly, it'll end up creating a symmetrical spindle. Let's start with the headstock. The headstock is pretty simple. It's just 2 pillow blocks, and the actual shaft is just a straight up 1/2-inch bolt, 1/2-inch with the 1/2-inch 13 thread. My entire system all the way along, later you'll see how I move back to the lathe. It's all based around this threading. The headstock is actually threaded to this. So everything's based around that threading, and I can interchange everything from there. And what this does is provides a great rotational method. It's very solidly on there when I put the spindle blank on there. And I know that it's really going to return to the same spot every time, as opposed to if I was using jaws or some other method. So it has the firmness, it has everything I want basically. I've got a pulley, a 1-to-1 pulley going back to a slow speed motor. So this motor goes from 10 RPM to 100 RPM. So I'm going to turn it on here. So this is 80 RPM. I can slow it down. Okay, hold on. We just slowed it down to nothing. 10, 20, 60, 70, 80. This is as fast as it goes. Don't ask me where you can get all this stuff, because I literally just got gifted from my father-in-law who had all this stuff, and it just ended up being the greatest thing for this little hack. So again, this is the control box. You've got RPM, forward and reverse, and on off, and it just works. It's just perfectly made for this. You want to go slow with this stuff, because if you're going too fast, I don't know, I feel like it would it wouldn't work as well. You want to kind of clip along. Like 80 is the perfect sort of speed for me, and I found that it's the best. This is the tailstock. I could say a lot about how this is made, but basically I'm just using a Morse taper tailstock, and it's just set in a block of MDF. I've got 2 holes drilled. I measured it at either end, and I drilled 2 holes. So it sort of just sits in there perfectly. It's actually really firmly in there. I know that it's not going to jiggle. It's always going to return to the same spot. And it is perfectly in line. I made it, built it up, and measured everything, and so now it's perfectly in line with that. Everything is the lathe bed, as it were, is just this the channel from my T-track hold down. Basically, on the underside of this, I've got something that I carved this on the CNC just to register, and it fits in there. So this slides along to accommodate basically any length stock that I would need. So there's a lower view. So now I'm going to mount my stock. Once again, the stock has it's been tapped in the wood to accept the 1/2-inch thread. Kind of got it a little deep. It could be more shallow than this, but I'm going to push in my tailstock. I'm going to actually just push it in with hand pressure, really. And I've got a little bolt on here to lock it down to the T-track. Okay, so now it's nice and firm in the headstock. It's going to have a really firm connection. It's always going to go back. If I need to remount it for whatever reason, it's always going to go back to that. And later on, when I interact with the other lathe, I know that it's going to spin correctly, not be off axis. Nothing weird's going to happen. Okay, that looks good. There's no vibration here. Solid in both places. Now again, the CNC is just going to come and carve that channel, boom, 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 all the way up here. And in the end, due to the fact that it's rotating, we're going to have a symmetrical spindle with an exact shape. I'm going to show you how I sort of faked a 3-dimensional lathe 4th rotary access carve in Easel. So I created an STL file. So everything just starts from Illustrator, basically. So I have a curve that I made, and I had to actually make a continuous curve without any flats because Easel will just not carve anything that's flat. It'll think that it's been done on the roughing. And I'm basically just going to do a single finishing pass with a single bit from here to here to here to here to here in one continuous long line, very slowly. So I basically took this thing and I made it into a STL file. So it's a 3-dimensional object. I did that in Tinkercad, which is a free online thing. I don't have anything else to make STLs from. I dropped the STL into Easel within the boundaries of a very thin, very small workpiece. And so I'm just kind of going and carving along here. So I'm going to generate the tool path now. So let's take a close look at the finishing. So it's really, you're going to see the bit drop and it's just going to do a single long line along this curve. Now when that's transferred, that motion is transferred to here. Say this was just a piece of wood standing still, it would just carve a channel along here. But due to the fact that it's rotating, it'll just continuously sort of helically carve very slowly. So yeah, you can see the bit dropping, boom, 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 and it's very slow. It'll play a lot slower in real life. The last thing I'm going to do is from Easel, you have to download your G-code. So I'm going to download. I'm not going to do the roughing. I'm just going to do the finishing pass. Just the finishing pass. I just want that. So I'm going to set the X point first on this imaginary. I'm going to start right directly dead center. This line here, just in a pencil line, represents that dead center. Hold on, so I'm going to use this. So I've got this whole block sort of emanating up from that. Yeah, and that's pretty centered. I'm centering on this ball nose. This equals 46 millimeters or 1 3/4 plus 1/16. So that represents the middle of the spindle. And let's go up. We're going to go up 16 mil, which is the theoretical top of the round. 2, 3. Okay, so 16. I'm going to zero that again. Okay, so now we finally set our Y. Now I'm going to go around and figure out where the Y starts. So I want Y to be just generally in line with this. If anything funky happens, I don't want it to go and start carving metal. So I'm gonna set Y like maybe 1/2 inch in. You know, I'm gonna go a little bit farther in actually. This is pretty arbitrary, this one. So now I'm gonna finally click 0 the Y. So we've got our X, Y, and Z, finally. I'm gonna actually put on the dust shroud too, because I don't want dust flying everywhere. So this is the order of operations. I'm gonna start the vacuum, I'm gonna start the router, and then I'm gonna start the motor, and then finally I'm gonna click carve, and you'll see it happen here. First I'm going to loosen the tailstock, pull it back. And I'm going to unscrew it from up here. So this is the carving. Geometrically, it's perfect, and it's always going to be perfect for each one. Surface finish is very good. This obviously is spruce or pine. It's just a 2x4 for this test. And it's very good. There's just no tear out. I'm going to take this over. Now you're going to see why I made this system. I'm going to take this over to a more high speed, my homemade lathe, and I'm going to do just the final sanding, just a light sanding really, and I'm going to carve off this end. So just a side mission for a second. Say if I was doing something like this, I carve the basic shape on the CNC, and then I can go in. You can't do anything that's this fine without really changing bits or doing something crazy, but it's really easy on a high-speed lathe to do all the sanding and to go in with a sharper gouge, and you just do these little details. And again, this is all the 1/2 inch. I've got the same tailstock. Screw this on here. And because it's so similar, the main thing is that you want this just to key into the system and replicate the rotational perfectly. So it's not bouncing around when you're trying to sand it or work on it. You don't have to kind of re-round it. Again, I'm just pushing this in here. Tailstock, I'm gonna bolt it down. It only needs a light sanding, so I can do that. For instance. So basically that's it. You're absolutely not going to have this same setup at home. This is so unique to me. I built all these systems based on other systems that I used and what the exact things that I had. Hopefully you can take this sort of hodgepodge of information. I know other people have kind of done it on their own already from some of the comments. But yeah, hopefully if you're looking for a temporary sort of DIY solution to add that 4th axis or that sort of repeatable spindle to your lathe, it's actually worth the effort to do. It's cheap. You could do it with the sort of cheaper programs like Easel. You need some sort of CNC capacity, obviously, to do it. But the CNC just, man, I was having so much tear out issues with doing stuff traditionally on a lathe. I've just, man, what a journey. I've never been able to do it perfectly, but this, something about that slow rotor doing a slow pass, slow rotation, it just gives me such a perfect, repeatable result every time, and that, God damn it, that's all I want, you know, and I can go in and I can manipulate this a little bit afterwards, but it gives me that great base with no tear out. That's all I want. I just want to get the legs done, and I just want to get on with all the other stuff that I really want to do. Ask me any questions you want in the comments and I'll try and explain. But yeah, that was the combination of that CNC, a rudimentary lathe, and using the Easel software to sort of fake a rotary 4-axis. And then obviously you have to go to some sort of traditional lathe to finish it, or to do your sanding, because you need that high speed and you need to be able to use, you know, some tools afterwards. Thank you for watching. I really hope this helps someone out there.